Good morning, everyone. I hope everyone's settled in. So this is going to be a 45-minute talk, and the next 45 minutes is going to be Marshall's. So I'll try to get through my 30-something slides, uh, and then do a demo. So the slides are just gonna help guide me talk about the library. So my name is Dean Michael Barris. So a little about me, because the paper didn't have much, just said sa Palok, Manila. And that's where I live, in the Philippines. So I filled out the form, and I didn't know it was going to show up. So I just said, well, where are you from? And I said, I'm from the Philippines. So that's why I showed up on the paper. So that's my name, that's my email address. I'm an entrepreneur, I'm from the Philippines. I started a small company, but it's not doing C++. So we do web application development using Ruby on Rails and C++ on the back end. So I personally have been doing network programming in C++ for the past 4 years, 3-4 years. I used to work with Friendster Incorporated. Hey, good morning. So who knows what Friendster is? So you have what, 4 people know? Okay, 5 people know. So Friendster was the social networking company, the first one, before MySpace. Who doesn't know MySpace? Okay, so
There's a bunch of chairs up front too.
Friendster is a little.
If you need a chair.
He's the biggest in
Okay.
the Philippines, so biggest social networking site in the Philippines, and in Asia. So it's not so popular here anymore. So I worked with them on the back end side, doing C++ network development. So right now, I am a consultant to the biggest telco in the Philippines. I help them set up network systems, software development using different programming languages. So I work with them on pretty much the whole stack. And then I am a C++ enthusiast. So I say that because I'm really enthusiastic about C++. So if at any time you have any questions or anything isn't clear, please don't hesitate to stop me or something. Right. But please take note, we're just 45 minutes. So I'll try to get through the slides as quickly as I can, and then show a few demos of the library. So the talk's title is Techniques in. Yeah, so that was a bad title. So essentially, I'm going to talk about what I do, what we do in the C++ network library. We call it CPP-NetLib. So when I say CPP-NetLib, it's the library we're working on. I'm going to talk about the techniques we use inside that allows us to keep the library header only. And when I say header only, the library itself just consists of headers, but then when you work with the dependencies, then you need to link to some external. So it's really not 100% header only because we don't implement OpenSSL, and only because Boost system needs to build, and regex, and datetime, and other things. So. Okay, quick overview. I'm going to talk about the rationale, why we're doing this, the techniques we use, and I'm going to show how we're going to move forward with the library just to give a good idea. So the rationale, we want to build a header-only C++ network library. So who has used libcurl? Who has used the Microsoft ATL? For who has used Qt network? Okay, let's do this. Who hasn't used a library to do networking? All right, so we have a handful. Has anybody tried implementing the HTTP protocol? Okay. Can anybody say if it's fun? Okay. So, well, yeah, you can make it a lot of fun. So, what we want to do in the library is to also implement common protocol clients. So, that means we want to handle HTTP, SMTP, FTP, yada yada P. So, it's a big goal. And that's the reason, well, it's the rationale and the reason. Oh, sorry, and the goal. So, we also provide a collection of peer-reviewed implementations. So we have a small mailing list. We're like 20 people on the mailing list, 4 of which are active, 2 of them is me. So no, I'm joking. So 3 of them is me. So we review it. Oh, sorry.
Sorry, I have to ask, why header only?
Okay. I'm gonna get there. Next
Okay.
slide. Okay. So we wanna replicate the Boost model, and at the same time build so that we can at some point have something ready for review for Boost. So consider this a somewhat public preview. Okay, yeah, well, header only. So we want to keep it simple and embed in applications that need the functionality. We want it in your binary if you're building an executable. We want it in your lib static library if you're building one, so that, well, it's simpler to deploy, to build into your application. Now, of course, when we have an update, you're gonna have to rebuild your application or your library, and actually that's by design. We want it easy for us to keep moving, while not having to worry about like binary backward compatibility, because that's really hard in C++. So we decided to, you know what, let other people worry about that. We're just gonna make it header only. So if you build it in, if it builds, we want it working, and that's that. Hey, so what protocols to implement? We want to do HTTP, SMTP, FTP, XMPP, ICMP. What other nice protocols? Right now, what we only have is the HTTP part, which is more or less a demonstration of the system we use internally to make the networking things happen. So yeah, we're just like Boost. So what happens is someone has an idea, like Marshall had an idea to implement MIME parsing and MIME generation. So he said, hey guys, you wanna take this on? The 4 people active said, yeah. Then we included his library. And in the latest release, which I just tagged last night, his library is already implemented in. So he's gonna talk about his library in the next, after the talk. So we wanna be just like Boost, except, you know, we're a little more lenient when it comes to, we can't be picky because there's not a lot of people wanting to contribute their HTTP client implementation. So community, I'm hoping, you know, that you guys are gonna join the mailing list if you find it interesting, if you have any questions, maybe suggestions, patches, get involved in the process. So yeah, we're working on it. We are built to be included in Boost. What does that mean? That means we follow the Boost coding conventions. So we also use the Boost namespace. So we live in Boost network. We're trying to claim that name already. And we do it because we think Boost is cool. The same reason why, you know, I tried to submit this talk, and you know, here we are. So, okay, enough about. Any questions other than why header only? Yes.
Well, why are you going to implement ICMP protocol? It's pretty low level protocol.
Yes. So
That's
good
really
question. Actually, we just want to make it simple to use. So if you say ping IP address, that's what we want to do. We want to enable that. Just allow you to say ping, give me an IP address, and then get the result for whatever. So think about it as a higher level wrapper around ASIO. So yeah, we used ASIO underneath. So Michael gave a talk yesterday about how to implement a server in ASIO. Well, we did that, only we don't want you to worry about how that happens under the hood. So later I'm going to show you, I'm going to talk about an embeddable HTTP server template that you can put in your application, call run, and that's it. 14 lines total, including blank lines of an HTTP server. So, yeah, to do that, though, so there's always a caveat. Caveat is that that simple program will take you like, on this machine, which is a netbook, maybe like 4 or 5 minutes to compile. So, you gotta pay somehow for the convenience. Right, yeah, please, come in. If you can still find... Thanks. Yeah? Okay, so you haven't missed anything yet. Okay, so any other questions before I move on to the specific techniques we use? Okay, so I want to talk about how the library is organized first. There are 3 major parts. There actually should be bullets here, but then it's so there's a mini framework in the library that deals that deals with messages. So there is a delineation in the library between a message and what you do with it. So there's a separation between the data and the algorithm, right? So messages are what you expect. It's a piece of data that encapsulates protocol-specific information to that message. So for example, you have an SMTP message object, and it encapsulates all the SMTP stuff that might be required for an SMTP message. Then you have a different type for the HTTP messages, right? So a request message and there's a response message in HTTP. In the heart of that is a basic message template. We're going to talk about that in a while. We do directives. I'm going to talk about that too. The idea with directives is you can tell, or you can encapsulate work in one directive and apply it to a message. So you have transformers that will actually transform a message into a different message. You have renderers. So for example, if you want to render a message into a string, and we have adapters. So for example, you want to turn this message into just a list of headers. For example, if you want to adapt a message to become, a stream. So we have a mini framework inside that allows you to do that. I'm going to show you an example of how to create a directive in a while. Protocol implementations, right now we have released an HTTP 1 and 1.1 compliant client and server. So we're gonna see that in a bit. And we have a collection of utilities, parsers for different things, because network text-based protocols are really just, the pain there is the parsing part. So, well, aside from the buffering and the network, other stuff. So, okay, we're gonna move on. And the first technique is we use a common message type. So multiple clients, multiple protocols, but there's only one message. It has to be uniform. So this message is basically a concept. This is what the basic message looks like. Yeah, that's it. Nothing there, except we just need a tag. All right, a tag type to basically say, okay, this basic message HTTP or something, or the default message implementation. So the semantics, these are called accessors, and these are just the types. So for example, every message instance, you can get the source, destination, the headers, and the body of the message. So if you look at a broad swath of message-based protocols, each one has at least a source, destination, headers, and the body, the payload. Right? Any disagreement there? Okay, so for example, there would be questions like, for example, if you were implementing IRC protocol, there are no headers there, right? But you can make the headers return nothing. So this is basically the concept description of a message.
But what if it's a multicast message?
Sorry?
What if it is a multicast message?
A
Cast.
Multicast.
a multicast message. Okay, so that is at the lower level protocol.
You don't have
Right.
it in the HTTP.
So you don't have a multicast message in HTTP, right? You only have the response and the request message. So think about message at the application level, application layer messages, not TCP messages or UDP messages. So because ASIO handles that, we don't want to touch that. We want to make it easier for people to just use ASIO in a transparent manner. Yes?
Well, even if you had multicast, how would it change it? The payload that you're sending in on whatever higher level protocol more than likely has something in the books. And very
Exactly
much
like
like
this.
this, right?
Yeah.
And anyway, destination type could be basically a collection of simple destinations.
Yes. Okay, so that's the next part. These source type, destination type, header type, body type, they have a trait meta function. And then you just, given a tag, you know what the type is. Make sense? Alright, so I'm not going to dwell on this. Just, okay. So you can use this to define the type of the string or containers to use based on the type. So for a multicast message, you might have a tag for multicast. And then you would have like the sources and destinations. Might be a string, might be a container other than a string. It's entirely up to you. You can also use it to optimize the storage of the basic message. So because the source function is external to the type, we don't do message dot something. It's something applied to message. You can actually make your message just a pod type. Be it a template, but still apply. You can also specialize for the protocol. For example, if you're handling streaming, your body might not be a string, might be a handle to like a stream-like interface. So you can pull out stuff from that. And you can also dispatch based on the type. So you can write generic functions that deal with the message using this idiom. So you let the compiler deduce this tag for you, just pass in a message, right? So, second part of the message is directives. So here, we have a message object. We set the source, we set the destination, a header, and the body. And then we can also remove a header. And then we can assert that the headers of the message that match foo is empty. The range of headers is empty. Look familiar? This is just boost range, right? Empty boost range, and this looks like your I/O streams interface, right? And yeah.
Where's the buffer for these headers stored?
So you can actually make it part of the message. So if you implement default, so the default implementation is a multi-map. We use a multi-map. So whenever you push headers in, so the idiom is you're sending a message. So in object-oriented programming, right? Smalltalk, you have an object, you send it a message, which is like a function invocation. Here, because we can't overload the operator dot in C++, we do it this way. So it's like you called message.source this, message.destination this, etc., etc. So why do we do it this way, right? What we want to do in a directive is basically take a generic message type, apply something to that message. So your logic is encapsulated in the directive, not in the message type. So your transformation is external from the type you're dealing with. So as a convenience though, so this is just a constructor. I'm sorry if the formatting is bad. I don't know how to make template code look good. So, all right. So that's the skeleton. That's basically how every directive looks like. It's a directive object, right? Function object. Then we just make convenience function, sum, which generates an object of that type, of the directive type, and we return that, basically. Now, it's wired in by the shift left operator, so this is already defined by the library, which basically dispatches on, okay, return a reference to the basic message, operator this, and then reference to the message, the directive, and you just apply the directive to the message. I could do this in Proto. Could make it, a little more complicated in Proto, but this seems to work for us right now. So in the next few steps, in the next few releases, we're gonna start moving into using Proto for this protocol. Questions? Yes, sir.
What's the benefit of using the operator overload if compared to directly invoking the function operator on the directive?
So it's more about this. So we want to be able to chain. We want to be able to chain it.
So that's officially is a chaining operation.
Yeah.
Okay.
It's a sequence operation, like Spirit. For example,
So
this,
that does it, but that results in nothing more than essentially calling source, calling destination, calling header, and calling body as a sequence.
Yeah.
So it's not a composition operation also.
Nope.
So that's why my question.
Although-
what's the benefit
Yeah.
of using the?
Okay, so the answer is we want to preserve this protocol first. We want to make it happen first. The easiest implementation is what I did. Now, you can imagine someone doing header foo bar, and then right next to it is a remove header foo,
Okay.
right? Then you can actually do the proto thing and transform and just remove the adding and the removing of the header, because it cancels. So, we don't need it now, which is why we don't do it with proto yet.
Okay.
And for the users, they don't really have to know. All they have to think about is this protocol.
Okay.
Right. Okay.
So essentially, sorry,
It's alright.
you're using this operator overload to be able to put everything into one expression.
Yes.
To be able to do some global optimization.
Yes.
On the expression later on.
Mm-hmm.
Okay, makes sense.
Right. So we stopped here?
Yeah, you finished that one. There you go.
Yeah, okay. So, basically, this is how you use your new directive. You say some foo type constructed out in there, and then you play well with the message framework. You can implement your own directives using that pattern I just showed earlier. For example, in a context of, I don't know, give me a protocol, FTP maybe? You want to be able to simplify the source, destination, headers, etc. You create one directive that encapsulates all that, and then just make it really easy. Make sense so far? Alright. So actually, you can implement this in your own library. You don't have to be in CPP Netlib to make this happen. So what I did is just distill the pattern I use, and you can use this in your own library. So that's technique number one. Technique number two is, okay, this is a mouthful. Okay, during the submission process, you know, the reviewers had to ask me, what the hell does that mean? Semantically consistent HTTP client. Anybody can guess? What does that mean? I can't either. So no, I'm joking. So the idea is you have syntax, which gives you the structure. You have semantics that give you the meaning of that structure, right? So the idea is we want to impart the meaning in the interface, right? So, just like a basic message, we use tag to determine for the HTTP client what string type to use. So for example, we have an implementation that supports wide strings. We have an implementation, we're working on an implementation that will use cute strings. We want to be able to do Microsoft strings internally, C string, and other things. We also use it to say if the client is active, an active object, asynchronous, or the normal blocking type, whether it uses connections or keeps it simple, support streaming, UDP or TCP, whether it throws or not. So we anchor a lot of these things just on the tag type that you use. So anybody read about policies? Who hasn't read about policies? Okay. They're okay, but they're really hard to use for the users, in my view. Right? The conceptual baggage required to be able to customize a type using policy this, policy that, you know, unless you're a glutton for pain, I don't really like it. So the way we do it is, okay, so these are just the tags we use. So we dispatch on default 8-bit TCP or UDP resolving. We have HTTP keep alive, 8-bit strings, TCP or UDP resolving, asynchronous, yada yada yada. We just have a lot of these types. You just have to know these types to be able to customize how the HTTP client behaves. You don't have to know the policies. You don't know anything about that. You just have these types to remember. And it fits in one page, don't worry. We don't have a lot of tags. So, choosing your parents, right? This is the way we do policies, which is you don't have to know them. We know them, we can choose them for you, but you just have to give us the type. Right? So the conceptual overhead for you guys, for the users, is really low. Just know that, okay, I want UDP resolving asynchronous HTTP client. We'll just use a tag for that. Yes?
Doesn't that make your tags effectively type defs for a collection of policies shot through one level of indirection?
Yeah, you can say that. But basically you treat your tag more like just an input to your functions that you can build around that tag. And because it's compile time, you can't go wrong. Or, you know, if you go wrong, you don't get the runtime. Okay?
But you will
Yes.
get combinatorial explosion.
Yes! Yes!
Okay.
But you don't have to worry about that.
Really?
That's the good part.
Why?
So
Why?
because the implementers, we worry about it.
Yeah, but still, if
The number of tags.
there's only one parameter I can put into the machinery, that one parameter has to express every combination, which means that the list that currently you claim fits on one page won't one day.
Yeah, one day, yeah. Or we can actually do some a little more clever things. Like for example, okay, we know that the default is usually this, so we have a tag that just sets all the defaults and specializes on one.
Well, then the question is, why don't you use the normal policy arguments and set defaults for that?
So the answer again is so that you don't have to worry about it.
What if you
Well,
want
with
to learn
defaults,
about
I
it?
don't have to.
Okay, so what if you want to worry about it? The answer is you write your tag,
Okay.
right? You write your own tag that specializes these things. Then you're going to the realm of the implementer.
There can be a two-level interface for the simple interface where you don't have everything there.
Right.
And then if you want more, then you can go to the second level interface where you can specify your policies and stuff like that.
Yep, which is this part.
Yeah, so it doesn't have to be part of the implementation, it can be a public API.
Yes.
Will it work if the tag is an MPL vector which takes all these possible combinations?
Actually, yes, because you can implement this, right? So it could be, yes, a type def to like an MPL vector.
But I just get the feeling that this is just exactly, it expresses exactly the same thing, but in a more verbose way.
More, sorry?
Verbose.
Yeah,
You need to type more to implement your own tag than to implement your own policy. And
Yeah, the
Combine it
interesting
together
thing
with
is that
existing policy.
inside your tag name, you mention the parameter choice anyway.
Unless you just say default.
yes, but that's just a type def.
Yeah, so you can make your type def.
I don't see the advantage of this approach.
Well, okay, think about it. If I made the policies part of this type, what if I want to change the implementation of the basic line?
Well, if you
Then I break everyone else's code because maybe I add something or I change the policy of how the policies behave, right? So then the users that used to not have to worry about it, just need to know the tag, now have to worry about, okay, I want to mix this policy with that policy, but then he changed the policy parameters.
Yeah, but a user who has his own policies already has to worry about that. If you change how
No,
the
no, no.
policies works and the user has his own policy written, then he has to adapt the policy.
No, so, okay, this is a dispatch, right?
Yeah.
So, okay, I'm not gonna go into the policy. We can talk about it offline. So I just have 10 minutes ago. But
Okay.
yeah, this is interesting. Okay, so still makes sense, right? The thought of this slide is you can choose your parent. How many number of parents you might want to have? It would be nice. Right? So, what we want to do is to map the semantics to the syntax. So if you want to get data from a URI, you just do that, client.get. If you want to do put, client put, post, client post, delete, client delete, underscore, sorry. This will not compile. Should be an underscore right here. Typo. Okay, make sense? So, anybody seen any HTTP client like this? You have?
Python.
Well, yeah. Oh, okay, let's qualify that. In C++. Okay, I haven't. Nothing open source yet. There might be some that are not open source, but that doesn't really count for me because I can't see it otherwise. So this is what we did. And this is a one-liner that will actually allow you to get the homepage of Boost and print it out to standard output. Does it make sense? I instantiate the client. I use the get method, pass in a request, which is just a URI to. Anybody seen anything like this yet? I hope not. Because then I'd be like, yeah, you're boring. Okay, this is the one-liner way. It's a little too clever, so we can break it up in a few steps. First, create the client, create a request. You hold the response from the request, and then you do something about the response. This is semantically equivalent to what you do when you're dealing with HTTP. Yes?
How do you handle asynchronous response if you don't want to block?
Ah,
Yeah, where's the tag?
Okay, so yes, right? This is the default implementation, right? I could easily type def client to have the tag HTTP async, have body dispatch to a method that will actually wait for a future, and response could be a future. You wouldn't have to know.
Do you have an example of that, or?
No.
Okay.
Yes,
So do you force all the async to be in a thread that you provide?
we can make that happen that way. Or we could actually, for that type, add an additional requirement to the constructor. Give us a handle to like a queue or something, an IO service queue from ASIO or something like that. Right? Yes.
What about errors and what about redirections? Like
Error-
say you typed in boost1.org. It's like, you know, those kind of things.
Right. So what's gonna happen there is it's gonna throw exceptions.
At which point?
At this point when you get it. Which makes sense. Because you failed when you tried to get something. Right?
Yeah, but in the asynchronous case, it might not yet know that it failed.
Well, it's still gonna be. Yeah, so it's gonna throw here. Yeah, that's a problem.
So ASIO provides both the throwing and non-throwing error handling. Have you thought about doing both as well?
Yes.
Have you done both?
No. I've thought about it, yes. But no. So what's gonna happen then is this is not the only overload of get. We have a few overloads of get. Right? So if you really want to say that I want to use a client that does not ever throw, then you might have a no throw argument right there. Then in the code, you know, there's no magic. You said you wanted to not throw, so you write it there. No guessing, no nothing whatsoever. Make sense? Yes.
I just think that in the case of HTTP, this is going to be something very common. Because if
Yeah.
it throws on an HTTP error, I can't get the body of that error out, which might actually contain interesting information.
Yes.
Especially if I'm a web browser.
Mhm.
I want to display that.
But if you're like me and the majority of the users that just want to do something, you don't mind catching an exception once in a while. Yes, sir.
How does it handle authentication?
Right now we don't handle it yet, but it could easily be pluggable when you construct a client. So you could pass in, or we could actually make an overload of get of all the others that passes in like special parameters, etc. Or actually, if it's HTTP auth, those are just headers. So you can pack in the headers into the request using the same protocol earlier, which is semantically equivalent to what you wanted to do, right? Make sense so far? Okay. So let's leave that. The question is, how do you handle HTTPS? You give it a string, right? HTTP : yada yada yada. How do I handle HTTPS if my interface is just client.get? It doesn't say client.get s, right, for secure. It doesn't say that. And sometimes you really don't have to say that. All I want is to just get something from this URL. Right? So we use something, well, it's one of the more basic techniques, but basically a pattern to allow us to do mixture of static dispatch and dynamic dispatch. Okay? So this isn't anything new. We tried, oh, this should be virtual too. Sorry. Tried writing this slide last night, so sorry about that. So virtual, this is a general case, right? So you have an interface, you have a strategy factory. This should be a factory actually. You have a strategy factory that's templated on a tag. And then you have a create, should be static function that returns a unique pointer to an instance of or a derived instance of interface. Make sense? Well, aside from the typos. Okay, that's the general idea. Then you can have many different implementations of the interface. Normal object-oriented programming, right? Then you have the strategy. This is the implementation of your create. You have a switch, or you might have a MSM to make this happen, right? Basically, return an instance based on the input. Okay, so where's the static part? Anybody guess where's the static part? So you can actually specialize on the tag. Based on the tag, this behavior will change. Some might not be available given a given tag. So the way you would invoke this would be, because this should be static, you have strategy, the tag, create. Right? Then you can limit this switch case for some, make it just one implementation for some, but the dispatch happens statically. And then when you actually use the strategy that you implemented, gets dispatched at runtime. Okay, silence. Okay, make sense? Okay, so we use this technique to handle HTTPS. Based on the tag, whether it's asynchronous, whether it's this or that, we actually plan on dispatching based on the tag whether you have OpenSSL or you're using a different SSL implementation. So then the number of strategies we implement would be manageable on our side, which nobody has to worry about except us. Users don't ever have to see this. You only have to ever see the tag if they ever want to use anything other than the default. So you can imagine a connection object or connection handling strategy which handles HTTPS differently, which handles HTTP differently, right? Yes?
At what point does it get called?
That's inside the library. Okay. Inside the HTTP client implementation. So we have like a skeleton for how to do how to do one synchronous request. I don't want to say a synchronous request because English. Okay, make sense? Any other questions? Anybody confused? Please be honest. Okay, or you can be honest later. That's fine. Okay, why? Why do you want to do this? So you retain the static properties of the interface, right? You dispatch on runtime values too, because you have the int. You pass it to the create. So for example, if you're getting a URL from a user at runtime, then you just pass it in. And you dispatch which strategy you use based on that. Right? But that never ever has to enter the minds of the user. It's just the library that does it. Okay? Support wiring of variable implementation parts just like with normal object-oriented programming. Make sense? Okay, I'm running over time, so is it alright? Okay, so to handle URIs, two common connections. So normal connection, OpenSSL connection. So that's how we dispatch internally. Okay, so what's in CVP Netlib now? Right? This is what would a normal usage scenario look like. You use the network, Boost Network HTTP namespace. You have a client. You can say cache the resolved domains, the IP addresses, so you don't have to do it every time. You can say follow the redirects when you see 304s, 302s. You don't have to worry about that. We do that internally. So you just create a request, pass in the URI, create a response object that will hold the responses. Just call response, get request, put request, delete request, post head request. This is what we want to give users. Just something really easy nothing complicated, something that just works. Right? And this is the HTTP server. So I didn't talk about the implementation details of the HTTP server because I only have 45 minutes. That would take a lot of time. So if you're interested, we can talk offline during the breaks. But basically, we just type def to a handler type, which is basically just a function object that takes a request and a response. The response is an L value, correct? And the request is it could be a temporary, it could be just an instance, but we make it const for some reason so that you don't mangle it or something. Or if you want to really, you can cast it, copy it and do something. But anyway, this is how you say hello. The response type has a stock reply. You can say this is the status, okay, and this is the body, hello. Then, but this is really, really ugly. So we don't know yet how to allow you to specify your logging thing. So we make it part of the handler. Because it's really, just really easy for us. It has to change at some point. But we just need a log function that we can call as part of the handler. This is enforced at compile time anyway. So if you're missing the log function, it's going to fail. So,
Sorry.
yes?
The fact that the response argument isn't mentioned below is
Oh, yeah.
another typo?
Sorry. Yeah, it's a typo. Res equals. Sorry.
Oh, okay.
Doesn't fit on the slide. And I was writing this last night, so I'm sorry about that. Res equals this. Yeah. That's all. That's all. That's all you need to do to say hello via HTTP. So notice I don't dispatch on whether it's a get, it's a post, just works. Yes, sir.
You also have the config information from the peer connection
Yes, it's actually going to be part of the request.
in the request.
So you can reach into the headers
Right.
and deal with the headers using the accessors earlier. And this is the line that makes it all work. This one. So you have an instance of hello. You pass in as a reference in the end. Say what the IP you want to listen to is, the port you want to listen to at, and just call run. Compile this, run this, you now have a hello HTTP server. Yes, sir.
How scalable is this? How many control connections?
So, it depends on how you run.
To do run.
So, you could do the technique of running a thread pool that just runs run. So, how scalable that is dependent on your machine. Yes, sir.
Does run basically just call the IO service run?
Almost.
More or less.
In some cases, yeah.
Can you inject your own IO service there?
We're thinking about that. So part of this, we want to be able to maybe take a shared pointer or something. So yeah, this is what we already have. You can download 0.6 that I just released last night. You can do this, all this, even the one-liner. HTTP GET. So the techniques we used allow us to do this and then keep changing the implementation underneath and keep the source interface just the same. You want to get the best of the best, just take it, recompile your stuff, make the compiler a little unhappy.
How long will that compile?
Yeah, good question. So this actually compiles like 4 minutes on a netbook. But,
Okay.
you know, you can save the 4 minutes when it's already running.
You can make it faster by taking out that comment at the bottom.
Yeah, that's So,
But well, with developing, that's quite a big turnaround time if you fix a one-line typo. So, sorry, I have to ask the question, why not put parts into a static library? The
Well, you
easier
can.
way to fix that.
you can, on your own.
You can
As a
also
user.
use Pimple idiom just to avoid compile times. It's up to you.
Yeah, but why is it in the design that you have to have long compile times?
Well-
if you want to change core logic.
So the long compile time, it's a compiler problem. No. So the real answer is because I personally want to be able to test this as I'm changing it, and I don't necessarily want to, if I do a static lib outside, right? Then I have to build all these different implementations. I'm changing, and then my problem becomes I write a lot of stuff instead of just waiting for something to happen. I like waiting. Sorry. I like waiting more than writing. So,
But aren't you
Yes.
testing the various configurations anyway?
yes, but I don't have to type all them before I test. So so my test suite, right? My test suite, because I just have tags, I use boost test, and I have a template function that I just, this is an MPL vector, these are the tags, I want to test it, boom, one test function. Then I wait like 20 minutes.
It might be good to have both. I mean, okay, for header, for those who want to use header only, okay. For those who want to have static lights, then I think it should be able to provide both.
Yeah.
Because, well, if fixing a trivial bug off by 1 takes 5 minutes, then I'm fed up after 3 tries.
There are valid reasons for wanting
Yeah.
to have a static light.
Yeah. And, well, so the reason I don't do it yet is the code is no longer trivial to make that happen
Yeah,
internally. I mean, it's
it's just template instantiations, right?
it's a lot. Yeah, it's a mess.
Okay.
That's the reason. So I rely a lot on the template static stuff. I haven't measured it yet, how fast it is, or
Well,
I was
certainly
happy
factoring
first.
that non-dependent code would be easy enough, and that may have some value in compile time.
Yeah.
so, yep. But then I have to write all the, dispatch all the tags, build that in, write a wrapper around it. That would be the way I would do it, right? Do the pimple thing, and then just have a factory say I want this, get the reference to this, etc. Yeah.
For my pure interest, did you try with precompiled header how much you gain?
No, not yet.
It would be interesting.
Good idea.
Just to know, I know I gain about 30%, it would be interesting to know in which case, in your case, how much you gain.
Yeah.
Yeah, that's a good idea. Thank you for that. Let's try that.
I'm sorry, word processing.
Any other questions? I don't want to demo the build anymore because it's gonna take too much of Marshall's time. So, yeah, thank you very much.